Welcome to all of you in Sankalp Education Pratham classes. I am Sachin Patil, delivered lecture series on derivative or differentiation. Right now we are going with the derivatives of inverse function. First of all, what is the inverse function? We have to know about the consideration of if y is equal to f of x, y is equal to f of x is 1 1 and onto function, then x is equal to f inverse y exist and it is called inverse function. What does it mean? First of all, we have to know about the y is equal to f of x. That means x is an independent variable and y is a dependent variable, and it is a 1 1 and onto function. What is the meaning of 1 1 and onto? It is the most important related to that one. 1 1 function is what does it mean? First of all, you have to consider the function f x to y, where x and y be the sets, and x having some values are here. Let us consider 1 2 3 considerations, and this is x is nothing but a domain, and we have to take the values of y here. That means you have to taking 1 2 3 and 4 so on. You will get the consideration of this is the set. This is the set of y and this is the set of x. It is called as a domain, and it is called as a codomain. At the time you will say that this is a 1 1 function when first of all every element, one element having a related value in y, that means one element of x set of domain is connected with one element of y, then it is called as a 1 1 function. That means f of x1, that f of x1 is not equal to f of x2, where x1 and x2 are not same. And x1 comma x2 belongs to x, and there will be related values of this y1 is not equal to y2. At that time we will say that the function is nothing but a 1 1 function. And onto means what? There will be every element in set y is connected with every element in y has a corresponding element in x. At that time it is called as a 1 1 function. That means we have to get the consideration of onto function. I am just giving the introductory concept related to that onto function. That means let us consider here a1 a2 a3 are 3 elements, and you will have the consideration of b1 b2 b3 is here. At that time this element is corresponding to that one, this element is corresponding to that one, this element is corresponding to that one. Also you have to consider here a4 is here and this element is corresponding to that one. At that time this function is onto function, because all elements in a codomain are present in range of that function. That means let us consider function f is here. F, once again you have to get the consideration of x to y, and y is nothing but a codomain, and x is nothing but a domain. At that time range of your function, range of given function f is equal to codomain. At that time you will call it as a onto function. Therefore it is called as a onto function. What does it mean? Every element in codomain has a corresponding element in domain, at that time this is called as a onto function. For example, we have to consider here this function is onto, but here it is a not a one function, because here a3 and a4 has the same element in y, and therefore it is a many to one function. It is a not a onto function, and therefore first of all you have to consider what is a one function. One function is what? One function means, once again here we have to get the consideration of this element is corresponding to this element is corresponding to this. At that time this is a one function, but here domain of that function, codomain of that function is not equal to range of that function, and therefore codomain and domain are not equal. At that time it is called as a into function. And one function also called as a injective, and onto function is also called as a surjective function. And if any function which is a 1 and onto, then it is called as a bijective function. And if any function y is equal to f of x is a 1 and onto, that means it is a bijective function. At that time you will get the x is equal to f inverse y exists there, and it is called as a inverse function. And this is related to your consideration of inverse function. What is the inverse function? Right now we have to get the consideration. For example, let us consider here f of x is equal to 2x minus 2 be the function, where f of x is nothing but a y, and therefore y is equal to 2x minus 2. It is your function. At that time you said that y is a function of x. That means here x is an independent variable and y is a dependent variable, and therefore you will consider what? Y is a function of x. Y is a function of x, and therefore you have to take the derivative of y with respect to x is here, and therefore you will get the dy by dx is equal to, what is the derivative of 2x is nothing but 2 is here, and therefore you can say that derivative of f of x is equal, derivative of f of x is equal to 2 is here. Right now we have to take the inverse of that one. That means you have to perform this function. Here y is a dependent variable and x is an independent variable. Right now we have to move in a reverse direction. That means x is equal to, how to calculate? X is equal to minus 2 is transferred here. That means you will get the y plus 2, and this 2 is a multiply, therefore it is divided here, and you will get the consideration of x is equal to y plus 2 divided by 2. And here you will say that function x is a dependent variable and y is an independent variable. Therefore you can calculate the derivative of x. That means x is a function of y, and it is also written as f inverse y, and therefore you will get the derivative of x with respect to y. It is written as, this is x is here and this is y is here, and the derivative of x with respect to y is nothing but dx divided by dy is equal to 1/2 is taken outside, and dy of y plus 2 is taken here, because 1/2 is a constant, take outside the derivative, and derivative of this is 2, derivative of 2 is a derivative of constant is 0, and y derivative with respect to y is equal to 1, and therefore you will get the 1 plus 0, that means 1/2. What does it mean? First of all, we have to get the consideration of derivative of this f inverse y is equal to 1/2, and you can say that this is inverse of that one, and therefore these two functions are inverse of each other. That means y is equal to 2x minus 2 and x is equal to y plus 2 divided by 2 are the inverse functions of each other. Right now we are going with consideration. Next example is nothing but let us consider y is equal to f of x is equal to x square, and let g is equal to f inverse. That means g is equal to f inverse be the inverse function of that function, and therefore you can say that g of y is equal to nothing but a square root, no, g of y is nothing but a x is equal to square root of y. How it is calculated? First of all, we have to think about the consideration of this one is nothing but a y is equal to x square, and therefore x is equal to root y, and therefore g of y is equal to x is equal to root y. Right now we have to take the consideration of g dash y is here, and g dash y is nothing but a 1 divided by 2 root y, because we know that the root x having the derivative 1 divided by 2 root x, and therefore root y having the derivative 1 divided by 2 root y. And also we have f dash x is equal to 2x. F dash x is equal to 2x, and right now we know that the consideration of this derivatives of functions, and you have to find out the composition of these two in consideration of this one is nothing but x is equal to root y, and we have to put it here. You will get the consideration of 2 root y is here, and therefore you can say that g dash y is equal to 1 divided by 2 root y. 2 root y is nothing but a f dash x. 2 root y is nothing but a f dash x, and therefore you can say that these functions are inverse of each other, and those are the example related to that one. First of all, we have to consider again this function is here, y is equal to f of x is equal to x square, and therefore x is an independent variable and y is a dependent variable. Therefore you can say that y is a function of x, and therefore derivative of y with respect to x, and therefore dy by dx is equal to 2x is here. And right now this is nothing but a y dash, or it is also called as a f dash x is here, and you will get the consideration of x is equal to g of y is equal to root y is here, and from this you will get the consideration of y is a independent variable and x is a dependent variable. Therefore x is a function of y, and therefore derivative of x with respect to y, it is given as dx divided by dy, and it is having the value 1 divided by 2 root y, and it is having the consideration of root y is nothing but x, and therefore you will get the 2x. From this you can say that it is a g dash y, and from this you can say that f dash x and g dash y are inverse of each other. That means you will get the consideration of f dash x is equal to 1 divided by g dash y, or g dash y is equal to 1 divided by f dash x is here, and therefore you can say that these two functions are inverse of each other. Right now we are going with a theorem related to that inverse function as follows. Theorem is considered as, suppose y is equal to f of x is a differentiable function of x. What does it mean? First of all, we have to get the consideration of x is an independent variable and y is a dependent variable, and therefore derivative of y with respect to x is possible. At that time this function is a differentiable function of x on interval I be the integral set, and in this interval you will get the consideration of y is equal to f of x is a differentiable function, and y is a 1 1 and onto. Once again you know that the 1 1 and onto, what does it mean? First of all, 1 1 means what? The every element in a domain has one corresponding element in a codomain. At that time it is called as a 1 1, and all elements in a codomain are corresponds to the as much as possible one element in a domain, at that time it is called as a onto. That means all elements in a codomain is nothing but a range of given function. At that time you will call it as a onto function at that time, and you will get the dy by dx is not equal to 0. Then f inverse y is a differentiable function, then dy of f inverse y is equal to 1 divided by f dash x, or it is also called as a dx divided by dy is equal to 1 divided by dy by dx, where dy by dx is not equal to 0. Right now we have to get the consideration of y is equal to f of x is a differentiable function. That means when the change in x is done, at that time you will get the corresponding change in y. At that time you will consider here two functions are there. Let y is equal to f of x and x is equal to f inverse y are differentiable functions. Right now, if any change in x causes the corresponding change in y, and therefore first of all you have to consider delta x be the small increment in x, then delta y be the corresponding increment in y. That means what? The delta y and delta x be the some increments performed in the consideration of if y is equal to f of x be the function. At that time when we got the change in x, at that time you will get the corresponding change in y. Similarly, if here x is a dependent variable, y is an independent variable, at that time when we perform the change in y, at that time we will get the corresponding change in x also, and therefore delta x is not equal to 0 and delta y is not equal to 0 also. Now we have delta x divided by delta y into delta y divided by delta x is equal to 1, and therefore you will get the consideration of delta x divided by delta y is equal to 1 divided by delta y divided by delta x, where delta y divided by delta x is not equal to 0. Because it becomes 0 at that time, this ratio becomes infinity and there will be no any meaning to that derivative. Therefore delta y divided by delta x is not equal to 0 is here. And taking limit on both side as delta x tends to 0, you will get the consideration of limit of delta x tends to 0, delta x divided by delta y is equal to limit of delta x tends to 0, 1 divided by delta y divided by delta x is here. Right now we know that as delta x tends to 0, delta y also tends to 0, and therefore you can perform the consideration of limit of delta y tends to 0, delta x divided by delta y is equal to here 1 divided by limit of delta x tends to 0, delta y divided by delta x is here. We know that y is equal to f of x is a differentiable function of x. Therefore limit of delta x tends to 0, delta y divided by delta x is equal to dy by dx, and dy by dx is not equal to 0 is here. And if dy by dx is exist and finite, then dx by dy, that is equal to limit of delta y tends to 0, delta x divided by delta y is exist and finite is here. That means what? You will get the consideration here. Right now you have to complete the proof of that derivative of inverse trigonometry inverse function, and you will get the consideration like that one. From this equation you will get the limit of delta y tends to 0, delta x divided by delta y. It is exist, and therefore it is a dx divided by dy is equal to 1 divided by whatever be the derivative, whatever be the limit of delta x tends to 0, delta y divided by delta x, because it is a differentiable function of x, and therefore you will get the dy by dx is here. What does it mean? First of all, we have to get the consideration of x is nothing but a f inverse y. X is nothing but a f inverse y. Therefore you will get the dy of f inverse y is equal to 1 divided by dy by dx is nothing but a derivative of y with respect to x, and it is nothing but a f dash x. And similarly you will get the consideration of the proof. This is a proof of the theorem, and you will get the inverse of the inverse trigonometry inverse function having the derivative which is nothing but a derivative of its inverse function, and you will get the consideration of dx by dy is equal to 1 divided by dy by dx, where dy by dx is not equal to 0 is here. If you will perform the theorem related to that inverse trigonometry function. If you like this video, then subscribe my channel and press on bell icon to get the next notification related to derivatives or that mathematics calculus part. Thank you.